Hi everyone, I am Prabha, Assistant Professor of Chemistry, PG and Research Department of Chemistry, A.D.M. College for Women, Autonomous, Nagapattinam. Today we shall discuss Heck reaction. Heck reaction, obviously Heck reaction is that reaction that has been formulated by Richard F. Heck, and he shared Nobel Prize in the year 2010 for chemistry with Tsutomu Mizuraki. So this famous reaction, which involves the reaction between an aryl halide and an alkene in the presence of palladium, where the valency state of palladium has a transition from zero valent to bivalent state in the presence of a base, is referred as Heck reaction, and the product that is formed during this reaction is a substituted alkene. So mainly in the synthesis of alkene and the desired substituents in the alkene system, Heck reaction can be utilized. The general outlook for the reaction is summarized here, where alkyl halide system reacts with an alkene and the transition state where the catalyst is palladium. The transition state of palladium catalyst involved varies from 0 to the bivalent state, and the reaction takes place in the presence of a base to give the substituted alkene. So varying proportion of the yield percentage of the products can be obtained, and also depending on the conditions of the reactions, which obviously implies varying the base conditions or otherwise solventless conditions. As in ionic phases, it finds its most significant application, or as ionic molecular surfactants can be obtained as products by this synthesis. And the yield percentage variation can be also brought about by varying the solvent system as well as the base conditions of the experiment. And also the stereospecificity of getting a trans product or a trans substituted alkene is at most effective in this particular Heck reaction. And as we say, varying solvent conditions, it may imply from methanol, triphenyl phosphine, or otherwise a tertiary amine system. So if it is a tertiary amine system, the varying composition or the desired composition of the substituted alkene can be obtained. And also, as we understand the mechanism of the reaction, various stages involved, or how the reaction proceeds on, or how can be classified under, it can be classified as a carbon-carbon coupling reaction. And the essential criteria for this reaction to take place is that the alkene system should contain an sp2 hybridized carbon. So sp2 hybridized carbon that is present in the alkene system makes a planar intermediate during the formation of the product, the intermediate that is formed, and thereby makes the cyclic transition or a cyclic movement such that trans products are predominantly obtained. Another one criteria there are variations that can be brought about in the organic substrate, where we can take it up instead of an aryl halide, a vinyl halide, or triflates also can be used in Heck reaction. So as we see to the varying conditions of the reactions, halo aryl system reacting with styrene, and in the presence of palladium, where the transition state of palladium being from zero valent to bivalent state, and here in the presence of the base, and particularly the addendum, which is alkene, is taken in the presence of solvent methanol. So this particular reaction has its specificity in consuming molar quantities of the addendum and catalytic quantities of palladium. So this is the most significant, where the reaction process proceeds in a stoichiometric ratio when compared to one of the reactant, and the catalytic ratio when it is taken in the part of analyzing the role of catalyst in this reaction. So the resultant product that is being obtained, or the alkene that is obtained, is styrene, which is of yield percentage 85, and the reaction being taken or carried out for 2 hours, maintaining the temperature around 125 degrees. The next other reaction, varying solvent conditions. As we vary the solvent condition, the yield percentage of the product, specificity of the substitution, and also the gram equivalence of the addendum that is being taken, and the role of the catalyst, everything differs in accordance with varying the reaction conditions. So here, as we take it up, bromobenzene, and here other styrene, same alkene being taken, but we vary only the solvent conditions, which is tertiary butyl amine system. And here the same catalyst as palladium, where it varies from zero valent to bivalent state of palladium, and taking up gram equivalents of the addendum, which is a alkene, and taking catalytic ratios of palladium catalyst. Again, the substituted alkene is obtained as an yield percentage of 80, where the reaction being carried out for 120 degrees and 2 hours, the reaction has been proceeding on. Next one other reaction, again a haloaryl system being taken. Haloaryl system can also react when the solvent is triphenyl phosphine, also when the addendum has an unsaturation, and that particular unsaturation has to contain an sp2 hybridized carbon hydrogen. So if it is so, that which component? This component containing oxygen active centers will involve itself in Heck reaction in the presence of a base and in the presence of palladium catalyst, where the transition of palladium varies from zero valent state to bivalent state, resulting in the formation of the product, where the yield percentage of the product is around 70%, the reaction being carried out for 2 days and temperature conditions being maintained around 100 degrees. So as we see to the mechanism of Heck reaction, it is a carbon-carbon coupling reaction, and here there is formation of, first there is a formation of the intermediate by the catalyst. So there is formation of palladium intermediate, and the process takes place by oxidative reduction process. So the first formed, or usually palladium is produced in situ by using palladium acetate, and the produced palladium in situ during the reaction process is in zero valent state, and during the formation of the intermediate it is in bivalent state. So that this is the first step where we say palladium obviously reacts with, here we are taking triphenyl phosphine. Triphenyl phosphine, the solvent conditions, there lies an oxidative reduction reaction that is taking place. So a part of triphenyl phosphine is reduced and the other part is oxidized. So the oxidized product is triphenyl phosphine oxide, and the reduced product being bis triphenyl phosphine, and that is associated with the palladium transition element in its zero valent state. So the next other step is the transition, where it forms obviously the transition of the valency from zero to bivalent state takes place during that stage itself, and when phosphine adds on to palladium. The next one, an oxidative addition. So the first, the formation of palladium intermediate, we have to specifically tell what the reaction process is. The next one, insertion of palladium into the aryl system, which means between the aryl bond and the halide bond, which is carbon bromine here, as we have taken it in this reaction process. So insertion of the palladium intermediate, that has to be in this position between carbon and halogen, thereby the second, which has been represented by number 2, the transition state of palladium to be specified, the reason that there is significance in their product formation and the planarity being maintained over here. The next one is next step, which includes addition of the alkene system. Here in this addition system, syn addition takes place. Syn addition of the alkene system, and that alkene system is inserted in between sp2 hybridized carbon and the already formed palladium intermediate complex that has been introduced in the previous steps. So as we take it up, the third that has been mentioned by the number is the intermediate, which is formed during this cyclic process. And the next step is the beta hydride elimination. So to understand the beta hydride, we have represented that the position of the hydrogen atom in that particular specific bonds, thereby beta hydrogen takes place, and resulting product, which is a substituted alkene, is being formed in the reaction process. Also simultaneously, palladium in its zero valent state is regenerated by using potassium carbonate. The other one reaction specificity that we have it up is modifying the conditions such that either trans products or aqueous phase equilibrium products can be obtained. So as we see to the products stereospecificity, trans products are being obtained, and the reaction mechanism involves mainly a coupling reaction between carbon-carbon bond and also involves oxidative reductive cyclic intermediate formation. And this maintains the stereospecificity where the steric group of the aryl system and the other one, which is the intermediate that contains a palladium system, are moving in a cyclic direction such that they place the substituents in transposition to each other to avoid a steric strain in the molecule. And here it is of synthetically important, or Heck reaction finds its significance in manufacturing, or it has a significant role because it can be implied in synthetic and other pharmaceutical and cosmetic industry of chemistry. Here, as we understand, there are two other products that can be obtained, which are naproxen and octyl methoxycinnamate. Octyl methoxycinnamate obviously used as sunbands, are one of the compositions that are present in sunbands and hence finds its application in cosmetic industry. Also, to cure the sores, hence finds its application in pharmaceutical industry. The next one, naproxen, here it is nothing but a bromine containing a naphthyl system, where it contains also an active oxygen center. So this particular reaction is between bromine that is present in a naphthyl system containing active oxygen and ethylene. Reaction takes place in the presence of palladium catalyst, and it is significant because it is solventless reaction and mainly finds its implication in obtaining equimolar or stoichiometric ratio, higher stoichiometric ratio of the products being obtained, and hence can be classified as a green reaction for the reason that it can incorporate all the reactants into the products where there is elimination of HBr and desired alkene is being formed as a product, and naproxen imparts in embedded compounds, it can impart polymeric properties as well as elasticity. So that's the main application that Heck reaction is concerned with. And an extended Heck reaction is nothing but Suzuki reaction as well as Negishi reaction. Suzuki reaction also proceeds in the same reaction mechanism as that of Heck reaction, but here the reaction is between an aryl halide system and aryl boronic acid, where the resultant products are obviously substituted alkenes. In Negishi reaction, as we take it up, aryl halide system, it can be also vinyl halide systems or triflates, such that it will react with a system which is containing a double bond, and that will involve itself in forming an intermediate associated with zinc. So organometallic zinc is playing a major role in the case of Negishi reactions because palladium forms stable compounds. We use it in Negishi reaction, and hence organo-zinc compounds are being specifically used as, or those intermediates that are forming organo-zinc components can be used in this reaction to get desired substituted alkenes. Thank you all.